Hi everyone, and welcome to our video on finding the equation to a curve that's already given. So most of the time we can find them by just plotting points and making sure we remember what the period and amplitude are in a problem. So for this first one, I'm going to highlight it in blue. What we want to do is highlight one period. So I'm trying my best to trace it. Not bad for a computer. Good. Right here. So right here in the blue, that is one full period of the cosine function. So as a reminder, just to the side here, like y equals sine of x. So these are the most basic, and I'm making it real small, but sine of x looks something like that. Y equals cosine of x looks something like this. Okay, so those are very, very, very quick sketches without much information, except at least it has the shape. And so I highlighted in blue it is cosine. It looks like it's a non-shifted, easy to do cosine problem. And so we'll continue marking. I'm going to mark the period here. So from where it begins to where it begins at 0 and ends at pi quarters. So that means that would be a length of pi quarters. So we have the period, and then what we can do with the period, so I'm going to go down here now. Remember that the period is the same thing as 2 pi over b. Okay, so we need that b in this problem. Nope, I don't really need the star. I might as well keep it though. Oops, actually now I'm going to erase it. Okay, so they have the period. We have it. It is pi over 4. So pi over 4 is 2 pi over b, and so that means we can solve for b. Okay, so we can cross multiply, or you could do different strategies, but if we cross multiply, we'd have pi b equals 8 pi. And then if we divide by pi, we're going to get b is 8. Okay, so I'm clouding it. We're going to come back to that in a second. The next thing that I want to mark, I'm going to do that in green, is the amplitude. So remember, the amplitude is the length from the x-axis, or really the symmetrical axis. Okay, so let me scroll for a second. So like, we wouldn't want to measure the amplitude of this one from a previous video from the x-axis. We would measure it from the new axis. So in case it's shifted vertically in some way, we would want to make sure we catch that. But here we know it's not shifted vertically because this length and this length, that length, are the same. Okay, so they're both 12. Okay, so we see it goes up to the 12 and down to negative 12. Okay, so our amplitude is 12. And because it looks like our most basic one right here, I'm doing a check mark, we know that there's no reflection. So we know that A is 12. And I'm going to cloud that. And then we're also saying on this problem, it's very much like our most basic cosine function. So it's not shifted. So if it's not shifted, so now I'm going to mark it. So we have a non-shifted cosine function. And the form of that is y equals a cosine of bx. Well, we have the a, we have the b, and so let's just plug them in, and that would be it. So y equals 12 cosine of 8x. Okay, so that would be our final answer for this problem. Okay, just like when graphing, if I want to, I can double check. Maybe I should see, hey, if I choose a point, at least one of them. So there's pi 8s and negative 12. It should work. If I plug in the x value, I should get that y value. So my quick little check here, I've got y equals 12 cosine of 8 times pi 8s. The 8s cancel, and I would have cosine of pi. Well, cosine of pi is negative 1. Negative 1 times 12 is negative 12. Check, it's good. Okay, so our official boxed answer was good. That can help again in case we accidentally maybe don't see that it was reflected. If there was a reflection, it can quickly tell you if you're right or wrong. or it can quickly tell you if you're wrong for sure. So if we don't get the same y coordinate, something's up and we need to go and figure it out, which is good. Okay, so in math, it's good to have these backups. Okay, this next one. So this next one, I'm going to make it a little harder because sometimes they don't give you, so this they give us more information than we need. Sometimes they might only give, say, this. And they might then also say you have to do a shifted curve. Okay, so I'm highlighting. There we go. That's where one period would end, or one full period is highlighted. And so on this problem, I'm going to say that they're let's pretend. So there's an easier way to do this, but sometimes again, they're going to force you to do things differently. Or we might need to be able to do it anyway for harder problems, and this would mimic it. We're going to do a shifted one. Okay, so this previous one, we chose not to shift it, and it's not too bad. We could choose the formula. So there's different answers you can do, but they can still work. Okay, so you don't have just to have a unique answer. You can have multiple different answers. All right, but with this one, we're going to do a shifted one. And I'm highlighting the part that's shifted. And we're saying, oh, it looks kind of like the sine curve. All right, because we have it on the axis. Okay, so that's where it looks like it starts. However, it is reflected. Okay, so sine goes up at the beginning. This one goes down. Okay, so right away, I'm going to say, well, we know it's reflected. So that will help with knowing that the A is negative. Like the last one, we can kind of go in different orders. So I can get the amplitude first. Okay, so notice from 0 to there, it looks like that's 3.5. That's the amplitude. And I'm going to use a decimal. Does that match the way it goes down below? So you want to double check to see if there's a vertical shift. And then, well, yes, this is the same length. Okay, so that means there's no vertical shift. Okay, so if it's shifted vertically, like before, let me scroll one more time, like right here. I mean, we could usually tell pretty quickly if it's shifted vertically. So more of it's either above or below the x-axis, and we know how it shifted. Okay, same deal with this sine one from a previous problem. Okay, so the axis is down below is shifted down too, so we can make that adjustment. Okay, so on this one, there's no vertical shift, but we are going to do a shifted one. All right, and even on this problem, so you can kind of jump around in the order of things. So I was just marking the first things that I saw. I said that we are going to do a shifted sine or a shifted curve, and we figured out it was sine and it's reflected. So we're going to do, I'm just going to mark this down to the side right now. I'm saying we're doing a shifted sine curve. So I'm setting up the form right now. And then we said, oh, there is no vertical shift. So that means I'm just going to scribble that out. Okay, so it's just that. So I don't need that anymore. I could have erased it. I'd rather just scribble. All right, so now that we have our trig function, we know it's shifted. We have the A already. We just need to fill in the missing letters. Okay, so we already have A, check mark. We need B, we need C. Okay, well, C is pretty easy to find. So the horizontal shift. So I'm going to do that in red. The horizontal shift, again, so usually sine starts right at 0, 0. This one, though, it got shifted to the left. Okay, so, and they use decimals, but we can see, well, 0.3333 repeated is what it looks like, and that is 1/3. So I am going to use the fraction. So that's our shift. So we went left 1/3. Okay, so let's start getting some of this information down. So we've got left 1/3. Okay, which I'm going to box. We have our A value, so we mark the amplitude, but we also said, oh, it's reflected. Double star that. So that means that A is negative 3.5. Okay, so I'm mixing decimals and fractions. I could change the decimal to a fraction there if I wanted to. Okay, so if we wanted to do that, that's fine. However, I think the 0.333 should be a fraction because it looks like it's a run-on decimal. And then the next thing we need, okay, so we're just again going through it. So now we do have the phase shift. So this involves that red. One more time with red. This is helping us with the phase shift. So the phase shift as a number, if we're going left, would be negative 1/3. So I'll box that too. Okay, so we've got this value. And then now we need the B value. Okay, so that I'm going to do in purple. Okay, so we want to figure out what the value is from where it begins to where it ends. That's the period. Okay, so this is, let's mark it like that, and then we'll show our work above the purple. Okay, so there's our purple. That's the period length. So it starts at negative 1/3, and it ends at 1 is what this looks like. So 0.3, 0.6, 1. So it ends there. Okay, so to get the period, it is just subtracting the bigger number minus the smaller number. So 1 minus 1/3. Well, oops, minus the smaller number. This is negative 1/3, so careful. Negative 1/3 like that. So 1 minus 1, negative 1/3. And then we can get a common denominator. I'm going to skip that scratch work and just say, well, it would be 3/3 plus 1/3. It will be 4/3. Okay, so don't accidentally go too fast like I almost did again. Okay, so because if I'd said 1 minus 1/3 would have been 2/3, and then we could see, yeah, that's not the full period because here's a length of 2/3. That's not where it would begin and repeat itself. That's too small. Okay, so we can visually double check ourselves too. Okay, so it's 4/3. 4/3 is the full length of the period. Okay, so if it is shifted, it is just the where the graph ends on the right minus where it starts on the left. Okay, now we do have our period. So our period is 4/3, but like the last problem, we need to make the connection and tell, or not tell, we need to make sure we remember the equation. The period is 2 pi divided by b, so we can change the p into 4/3 and then solve for b. So I'm going to cross multiply. So 4b is equal to 6 pi. And then when we divide by 4, we're going to have b is 3/2, or let's write it like this, 3 pi over 2. And I'm going to box that too, actually. Okay, now we've got that. And then now we'll just plug them all in. So our final answer is y equals negative 3.5 sine. Our b value is 3 pi over 2, parenthesis, x. Now careful here, it really is minus negative 1/3. Or with shifts, you can think opposite. So plus 1/3, parenthesis, bracket. There we go. Okay, so that's our answer. And like the last problem, once you have the function, if you want to double check, so for instance, I'm gonna choose this point up here. So this point is, so 0.6667 is 2/3. And then the y coordinate should be 3.5. Okay, so that's an x coordinate and y coordinate. So if I plug 2/3 in to this equation for x, so let's get it, sine 3 pi halves, and then 2/3 plus 1/3. So if I plug that in, which I just did, I should get y is 3.5. So let's find out. Well, this in the parentheses, this right here, 2/3 plus 1/3 is 1. So I don't need to write times 1. I could just say that this is sine of 3 pi halves. Well, sine of 3 pi halves is negative 1. So negative 3.5 times negative 1 is that y coordinate. We got it. Okay, so it looks good. And again, we could plug in these other points too to really verify. But I think we're good. Okay, so that's finding the equation of a curve. Okay, so sometimes it needs to be shifted, sometimes it doesn't. Narrow it down. You can have different answers that are equivalent. Okay, so that still give you the graph. I would say no matter what, double check. Okay, so thanks for watching. If you have questions, please let me know.